Alright, welcome to the podcast on testing functions. We are going to show you how to test if an ordered pair, a table, or a graph is a function. Testing equations is a little bit tougher, and we're not going to get into that at this point. You can assume if I give you a function as an equation, it is actually a function. Alright, so we're going to start with the definition of a function, and that is that for each input, there's only one unique output. So let's start with an ordered pair. Ordered pair is just a set of points written all in a line. So 2, 3, 5, 8, 6, 3, and 5, 9. What you want to do here is just check to see at each input you get the same output every time. So if I input a 2, I get a 3 out. Do I ever input another 2? I do not. If I input a 5, I get an 8 out. So do I ever input another 5? I do. Input a 5 here and I get a 9 out this time. So sometimes I put in a 5, I get an 8, and other times I put a 5, I get a 9. So this is not a function. For each input there should be only one output. And since I have two outputs, sometimes an 8, sometimes a 9, this is not a function. Let's do another one. 1, 3. 1, 3. Negative 8, 2. 5, 13. 1, 3. 2, 7. And let's do 51, 13. Alright, so let's check all of our inputs and see if we get the same output every time. So 1, when I plug in a 1, I get a 3 out. Do I have any other 1s? I do. Here's a 1, 3. And I get a 3 out as well, so I'm good. Negative 8, 2. Negative 8, do I ever plug in another negative 8? I don't, so I'm okay. 5, 13. So here's my 5. I plug out a 13. There's no other places I plug in a 5, but I do get a 13 out again. Is that okay? Is it okay that I plug in a 5 and get a 13 and 51? I get 13. It is. As long as I plug a number in, I get the same number out, I'm okay. 2, 7. I plug in a 2, I get a 7 out. There's no other plugging in 2s. And lastly, 51, 13. And that's okay as well. So this is a function. Oops. For each input, I get the same output every single time. And that's how you check your unordered pairs or functions. We can do the same thing with tables. So maybe the functions, it's the way that you view it's going to be a table instead of ordered pairs. This would be my input, my x, and my output would be f of x. And we can list our ordered pairs as table form. So 0, 1, 2, 3, 4. And then 3, 2, 1, 0. Just to make it interesting. Alright, so 0 I get a 7, 9, 11, 13, 15, 17, 19, 21, 23. So let's check. So when I put a 0 in, I get a 7 out. Do I ever put another 0 in? I do. 0 and I get a 23 out. Right away, this is not a function. Oops. This is not a function. Once you verify that it's not a function, you can quit and just say it's not a function. Let's do another one. This time let's say this is my M and this is G of M to give it a different name. So inputs are -8, 5, 10, 13, 5, and 22. Right, so my outputs are going to be 0, 1, 20, 16, 1, and 33. Check all my outputs and make sure I get the same thing out every time. So when I input an 8, -8, sorry, I get a 0, and I don't plug in a -8 again, so I'm good. If I plug in a 5, I get a 1. If I plug in a 5 again, I get a 1 out. So do I get the same output? I do. So that's good. Oops. 10 I get a 20, 13 I get a 16, and 22 I get a 33. So this is a function. Alright, so that's ordered pairs and tables. Let's now do some graphs. A graph, I could have a graph of just some points. So let's say I had a graph some points. I'll have a point here, a point here, a point way down here, and a point way up here. And let's just check each point to see what its value is. So remember, this is going to be my input, so this will be my x, and this will be my output line, my axes, f of x. So let's check each point. So this point's going to be, my input's going to be a -1, 2, 3, 4. And my output's going to be a 1, 2, 3. This one's going to be a -2. And my output's going to be -2. -2, 2. This one, my input's going to be 1, 2, 3. And my output's going to be 1, 2, 3, 4, 5, 6. And this one, again, my input's going to be 1, 2, 3. 1, 2, 3, 4, 5. Right? So now I have a list of ordered pairs, and I can see right away that this broke my function rule. Because I have an input of 3, and I can either get a 6 out or a 5 out. Another way we can think about this is something called a vertical line test. Right down here. This is just a quick way to think about, my vertical line is going to be my input. So if I put an input right here at -4, my output's going to be -3. An input right here of -2, my output's -2. My input here of 3 gives me 2 points right here and right here, and that's bad. So the vertical line test says that for each vertical line you can only have 1 point at that line. This one failed, so it's not a function. Let's do another one. Instead of having points, let's do a nice curve. So I could have a function that looks like this. Up and down and up. This is a nice either sine wave or maybe cubic. I'm going to do my vertical line test, and I'm just going to look for points that maybe would break the vertical line test. And there's no point on here that's going to break the vertical line test, so this actually is a function. So here's an example of one that's not a function. My set of axes, and let's say that it looks something like that. I do my vertical line test, and you can see right away it breaks it in multiple places, right? So this is not a function because of the vertical line test. Vertical line test failed. All right, we'll do a couple more. So let's say I have a function that's a shape. We can have functions. I shouldn't say we should have a relationship that's actually a circle, and you can see right away. It breaks it here and here. It breaks it here and here. It breaks it in all kinds of places. So this is not a function because the vertical line test failed. All right, and that's how you test your functions with the vertical line test. Have a great day.